right, so this one will not take as long as the other video did. It's a lot less. We're just doing differentiation and integration of a Taylor series in this video. So if you need, after you finish this, I would advise you to do some of the homework together in class and work on it together. And you can check your answers on Blackboard because I'll post all the answers to the homework from last week and this week, or sorry, last class and this class. And if you have any questions, hopefully you guys can answer each other's questions. And if you can't, then don't forget, you can ask me next week when I come back. No worries. Okay, so just as a recap, if you have the, if you remembered the 3 series that I asked you to remember, then the next 3 questions should be easy for you to do. If we look at this, we have got 1 factorial, 2 factorial, 3 factorial, and then we've got n factorial. And if you remember the e to the x function, that one was the one where it like went 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial, right? And that's what e to the x looked like. Hey, well, these two look kind of similar. 1 factorial, 1 factorial, 2 factorial, 2 factorial, 3 factorial, 3 factorial. The only thing is I have x and I have 3, so x equals 3. X squared equals 9. X cubed equals 27. And then so on and so forth. Well, this sequence matches up if x equals 3. Well, the sum of this actual series is e cubed. So if you found the sum of this series, it would be equivalent to e cubed. All right, so these are things that you need to be able to recognize because they're going to have this on the test where like they're going to have a number plugged in and you're going to have to be able to figure out, well, the sum of this series, what is it going to be equivalent to? So let's look at the next example. We've got 2 minus 8 over 3 factorial. Well, hey, first thing you notice, 3 factorial, 5 factorial, 7 factorial, 2n plus 1 factorial. That kind of looks like a sine function. Sine x is x minus x cubed over 3 plus x to the 5th over 5 minus x to the 7th over 7. Okay, and if we look, x equals 2, that's good. X cubed would equal 8. Well, then that's true. That matches with the x equals 2 hypothesis. X to the 5th equals 32. That looks right. And x to the 7th equals 128. If x equals 2, then that's true too. So this sum of this series is actually equal to sine of 2. Sine x, if I replaced 2, for every x, this would match this function. So sine of 2 and this sum of this infinite series will both equal the same number. Okay. This one does not have any factorial, so we can't do the factorial thing. But what I do notice is that this right here to the nth power shows me that this is a geometric series. And you should remember that the sum of a geometric series is equal to a1 over 1 minus r. a1 in this case is 1. And r in this case is negative 2/3. So this sum of the series should equal 1 over 1 minus negative 2/3, which is equal to 5/3. So the sum of this series equals 5/3. The sum of this series equals sine of 2, and the sum of this series equals e cubed. Okay, small little recap, just nothing really to do with differentiation and integration. It's just, hey, you can plug in a number for x and find what this series will be equal to for those three. The last things that we did, or the things that we did last class, covered manipulating special series. So we did substitution right here. We multiplied or divided the series by a constant and or a variable. We added or subtracted two series, and we recognized the sum of a geometric power series already. The only thing that we haven't done is differentiation or integration of a series. And that's super simple. We kind of did it in the last problem here, right here, where I asked you to integrate 1 minus cosine t over t squared. We kind of did it there, but we didn't really go into it like a ton. So what this theorem is saying is that you can take a series and you can derive it and integrate it, and it will be equivalent to the derivative or the integral of the original function. The only thing that you have to be careful of is that the radius of convergence of the series obtained by differentiating or integrating is the same as the original power series, so the radius of convergence doesn't change. The only thing that does change is the interval of convergence, because it could possibly converge at the endpoints, or it could not converge at the endpoints. So you're going to have to, anytime you derive or integrate, you need to do endpoint analysis. Okay? All right. It's the last page, guys. Hope you're excited. Let's do some examples. Here's a function, 1 over 1 minus x. Write the Maclaurin series for f. Okay, so I look at this and, hey, I recognize that this looks like a sum of a geometric series with a1 being 1 and r being x. So I can write this as a series. A Maclaurin series is just a series centered at 0. So a1 r to the nth power. Give the first four terms and the non-zero term. Okay, first four terms and the general term. That's what I meant. For what values of x does the series converge? Remember, a geometric series converges when r is less than 1. So therefore, this series will converge from -1 to 1. Okay, use your answer to A to find the Maclaurin series for f prime of x. Give the first four non-zero terms and the general term. For what values of x does the series converge? So, if I wanted to find f prime of x, then all I have to do is I just take the derivative of this. 1 plus 2x plus 3x squared plus it would be n x to the n minus 1 it's still going to converge on the same interval. The radius of convergence doesn't change. It's still going to be negative 1 to 1. But since I took the derivative, I'm going to have to do endpoint analysis. On the 1 and negative 1, since I took the derivative. So when x equals 1, I plug 1 into my series. And this equals infinity, so this diverges by nth term. Because it's not even alternating, it's just the sum of n. So it's 1 plus 2 plus 3 plus 4 plus 5. And so that's going to diverge by nth term. At negative 1, then the sum is n times negative 1 to the n minus 1. Which also goes to infinity, because this one, although it's alternating, the limit doesn't go to 0, so this is going to diverge by nth term as well. So this leads to no change here on our interval of convergence. Okay. Use your answer to B to find the sum of the infinite series. They will ask you to do this a ton of times on the AP exam. So you're going to have to associate this to what you found here, and then potentially go back to your original f of x function. So be careful. I'm definitely going to ask you a question like this on the test just because they do this so many times. So just follow me, and if you don't get it the first time, you can watch this video again, and hopefully you'll understand it. And if you don't, come in and get help because this is important. Okay, so this is 1 plus 2/3 plus 3/9 plus 4 over 27 plus blah, blah, blah. Okay, matching up with this, 1 and 1 match up because it says use your answer in B. 2x and 2/3 match up if we're going to do the same thing kind of like we did on the first page. So how does 1 and 1 match up? How does 2/3 and 2x match up? How does 3/9 and 3x squared match up? How does 4/27 and the next one match up? Well, if you notice, 2/3 will equal 2x if x equals 1/3. I'm going to write this a little bit further out. So this is where x equals 1/3, right? Well, if this matches up with this at x equals 1/3, and this is f of x, or f prime of x, then this function would be f prime of 1/3, right? Because this function, this series is just this series with 1/3 in for x. Okay? So here's what you got to do. Now we have to find f prime of 1/3, which means you go back to your original f of x, which is 1 over 1 minus x. So I go back to my original f of x equals 1 over 1 minus x. I find the derivative of that. This can be rewritten as 1 minus x to the negative 1. So I find the derivative of this. And then I plug in 1/3. Oh, sorry. I forgot to do chain rule. So those two kind of cancel. And that equals 9/4. So I went back to the original function, found the first derivative, found that the first derivative at 1/3 is 9/4. If this is also what the first derivative is equivalent to, then this series is equal to 9/4. Okay? All right. So super difficult to follow because you're going from a function, you're making a series out of that function. You take the derivative of that series. The derivative is equivalent to the series at 1/3. You go back to the original function, you take the derivative of that, and you plug in 1/3, and that's what your series that they give you is equivalent to. So that's what they're going to lead you. They're going to lead you full circle. Okay, let's just do one more example of this. Your homework has a lot of problems that kind of mimic this process, so hopefully you'll get it by the time you're done with your homework. Now we're going to integrate. So we're going to take this series that we initially started with, 1 plus x squared plus x cubed, and we're going to integrate it. So the integral from 0 to x of f of x is equal to, well, the integral of 1 is x. The integral of x is x squared over 2. The integral of x squared is x cubed over 3. Okay. So there's my first 4 non-zero terms and the general term. Well, my ratio of my interval of convergence will still be from -1 to 1. But I have to do endpoint analysis on this. So let's do endpoint. On those two values at the end. So at x equals 1. And I plugged in 1 in for x here into my general term. That's still just 1 over n plus 1. And so this is going to diverge by harmonic. Okay. So at 1, I don't write an equal sign. But this one is alternating. It's decreasing in magnitude, and the limit goes to 0. So this one is going to converge. Okay, so this one converges by alternating series, so I write an equal sign on this -1 right here. Okay, let's do this again. Use your answer to D to find the sum of the infinite series. So what we need to do is we need to go back and look at this and say, how does this match up with this? So how do I get from x to 1/3, from x squared over 2 to 1 over 3x squared, 3 squared times 2? How do I get from x cubed to 1 over 3 cubed times 3? Well, this happens, again, when x equals 1/3. Well, if x equals 1/3 and these two series are equivalent to each other, then I can say that this will equal this will equal this if x is 1/3. Right? Now, we go back to our original function and we integrate 0 to 1/3 of our original function, 1 over 1 minus x. The integral of 1 over 1 minus x is -1 natural log absolute value 1 minus x, because you do u sub, evaluated from 0 to 1/3. You plug in 1/3, and you plug in 0, and you get negative natural log of 2/3. Or if you want to, you can do natural log of 3/2 too. Sorry. If you like to get rid of the negative. Okay, so the sum of this infinite series is actually equal to, I did it on the other side, natural log of 3/2. Okay. So they do that a ton. They make you make a series for it and then go back to your original function and derive it or integrate it to show what the series is equivalent to. Alright, this is a shorter video, much shorter video than last time. Hopefully you understand, and if not, then I am giving you time now to work on the homework packet, because next class when I come back is review day, and then the class right after that is test day. So you definitely need to do the homework. We'll do review together when I come back. If you have any questions, feel free to email me or send me a text to my Remind 101, and hopefully I'll try to be there to answer it at some point during the day. Okay, miss you guys. Talk to you soon. Bye.